Hello, I'm back to talk about math. Not everybody's favorite, but incredibly important as a nurse to know how to do your med math. So if math is not your strong suit, try to put that behind you and get really good at med math. This chapter covers block 1, math. We're going to be discussing dosage calculations, and I just want to give you a heads up on the importance of understanding how to calculate the math correctly. It's critically important for the success of our nurses and our patients' outcomes. You're going to be doing these dosage calculations daily with every patient, and you need to know how to do the math. You're going to have to do a dosage calculation proficiency exam, and you have to pass it with 100% proficiency. If you don't pass that proficiency successfully, then you will be unable to pass medications in the clinical setting. So it's really important that you get a good grasp of this information. If you think about it, the reason we require a 100% pass rate on the math proficiency examination is because, let's say you missed one. So if there's 10 questions and you miss one, 1 out of 10 of your patients are going to not get the right dosage of medication, and that's not safe. So it has to be 100% to be proficient. If you need help with math, you do have resources available to you to make sure that you understand this and that you're grasping the concepts here. There's the tutoring department, you have us for office hours, and you probably have each other. Some of you will be better at math than others, so find out backgrounds of your peers and get together and study together. So when you're in the education world of testing, it's assumed that you have been given a doctor's order for every available answer on that test. This includes when dealing with medication orders on exams. We're going to be testing you on, are you able to calculate the dose and write it properly? So those are the things we're testing you on. Are you able to calculate the dose and then write it properly? There's a lot of things that make that up. Please don't rush the pharmacist by calling and asking how long a new order will take. The pharmacist and the pharmacy staff are making sure that this order is not going to kill your patient. They will be looking up numerous aspects of the order, like the drug-to-drug interactions. Maybe they're on a different medication and they got to make sure that they are not going to have a synergistic effect, or that one's not going to cancel out the effects of the other. They need to also make sure it's the proper dose. They're also looking to see what the patient's liver function looks like and the kidney function. Because if you're going to learn, as you're going to learn next week, we have a process that we call ME. And part of the ADME process is looking at the liver for metabolism, because the liver is going to be responsible for that. If the liver is damaged in any way, then the liver enzymes are going to be elevated. As a result, the doctor will most likely adjust the original dose to a lower dose, if possible, to not further risk damage of those organs. So the pharmacist is going to have that conversation with the provider. Same thing goes with the kidneys. If the kidneys are damaged, the kidney labs that we will look at are going to be elevated. So that's telling us that the drug dose must be decreased as well. And they're going to have that initial conversation with you, the provider, and then they're going to alter that drug order. Put in the new order with the comment field of dosage decreased because of kidney and or liver function. There will be times that you need to know what the standard doses are for some of the medications that we are going to be educating you on. There's not that many that have a set standard dose, but there are some that absolutely do. We will be covering this later on in the block. And there are medications that some facilities require a second nurse check. For example, insulin. Not everyone requires a second check for insulin, but many do. And it's due to the real possibility that an insulin medication error could kill your patient. Some hospitals and facilities require that you confirm the dosage with a second nurse for that reason. So now let's talk about the metric system, because we do use the metric system as a universal standard for dosing of medications. Medications come in micrograms, milligrams, grams, milliliters, liters, etc. So you will see that our solids are grams, and in parentheses you will see the abbreviation that is used for each one of those. So a gram is the G, 1,000 micrograms is an mcg, and 1,000 milligrams is mg. So 1,000 micrograms is 1 milligram. 1,000 milligrams is 1 gram. 2 grams is 2,000 milligrams. Liquids are measured in liters. So 1 liter is 1,000 milliliters. 1 milliliter is 1 cubic centimeter, or 1 cc. We don't really use that. Every once in a while, I'll see people write it, and my mom's a retired nurse, and she uses it. So 1 ml equals 1 cc. 2,000 mLs is 2 liters. So see how 1 liter is 1,000? It makes sense that 2 liters is 2,000. So please note that any number larger than 999 must have a comma. And I'm not kidding you, if you don't put the comma on the test, you miss that answer. If you do not put a comma in a number that's greater than 999, it's a wrong answer. So for example, if your answer is 1,234 milliliters, and you were to write 1,234 ml on your exam, it would be wrong. It would also be wrong if you put 1,234, but no ml. In the world of testing, it is a wrong answer. Anything greater than 999 must have a comma. You may also hear some of the older healthcare providers refer to a milliliter as a cc or a cubic centimeter. I just said that. We don't use it much anymore, but you can still hear people say it. You must also know how to convert pounds to ounces. So there are 16 ounces in 1 pound. One of the biggest things I see people doing incorrectly is, let's say that we give you a problem and we say, here's your medication. You're going to give 5 mLs per kilogram per hour. If I say that, then let's say that a patient weighs 9 pounds, 4 ounces. I see people take 9.4, you have to know kilograms too. So if I'm going to take 9.4 pounds and I'm going to convert that to kilograms, first I need to know how many pounds are in a kilogram. And not only that, but I need to know how many ounces are in a pound, because I don't do 9.4 pounds. I convert my pounds all to the same thing. So I have 4 ounces. I have to divide 4 by 16, which is going to give me 0.25. So I have 9.25 pounds. If I do 9.4 pounds, I just made a better. Hopefully that made sense to you. If not, then it will later when we do the actual examples. So 1 teaspoon is 5 mLs. 1 tablespoon is 15. So how many teaspoons are in a tablespoon? 3. 5 divided by 15, or 15 divided by 5, I guess, is 3. 1 ounce is 30 mLs. You are just going to have to commit these to your permanent memory, because those units of measure will always be around in healthcare. We still have providers out there that order things in teaspoons, tablespoons, and ounces. Or on your exam, you'll have to add up what somebody's input or output is. And it'll be like, they had 15 mLs of this medication and 400, I don't know, not 400 ounces. That would be ridiculous. Let's say they had 20 ounces of water and they had 420 mLs of orange juice. What was their input? You need to be able to, and it'll say input in milliliters for this time frame. You have to convert everything to mLs. So you need to know there's 30 mLs in an ounce, and they had 20 ounces, so 30 times 20 is this much. You know what I mean? So some of it are already be given to you, but you have to first put everything in the right measurement and then add it up. So here's some other systems. So there's going to be some other units of measure for medication doses that you will have to know. They are called international units or milliequivalents. They are unique in the sense that they don't convert to anything else. So there's never going to be a question where we're going to ask you to convert milliequivalents to milligrams or an international unit to a milliliter. That will never happen. If it did, it's a trick question, and the answer is that you can't do it. So this is the method that, well, there's different ways. We talked about this conversions. So now the other thing you have to know is that converting pounds to kilograms and feet to inches to centimeters. The universal standard is to measure everybody's weight in kilograms and height in centimeters. So how do we do that? You have to memorize the conversion factors. So we take the person's actual weight, not what they tell us they think their weight is, but their actual weight on a scale. We take that number and divide it by 2.2. Then you're going to round it to the nearest 10th place using standard rounding rules. So when rounding to the nearest 10th, you'll look at the hundredths place to decide if you should round up or down. If the number in the hundredths place is 1 through 4, you round down. But if the number in the hundredths place is 5 through 9, you round up. So here, let's say you have 189 pounds divided by 2.2. You come up with 85.9090. And that will round to 85.9 kilograms. Why? Because this is your tenths place, this is your hundredths place, this is a 0. Anything 0 to 4, I would say, is going to round down, so it's 85.9. If this number was a 6 or a 5, it would be 86 pounds or 86 kilograms. Inches to centimeters. So how do we convert that? We need to know first if we are given somebody's feet or somebody's height in inches or feet in inches, then we have to convert the feet to inches. So let's say somebody's height was, I don't know, 5'7". That's what mine is, or it used to be before I shrank. So you would take 12 inches in 1 foot, and I'm 5 feet. So 5 times 12 is 60. And then you add 7 more inches. So it would be 67 inches. In the example here on the screen, so we've got our inches. Then we multiply by 2.54 because that's how many centimeters are in an inch. And we round to the tenths place again. So if my patient is 6'1", I take 6 times 12 and add an inch. So 6 times 12 is 72, plus 1 is 73. Then I times that by 2.54 centimeters per inch, and I get 185.42. And I'm going to round to the nearest tenth, so that's 185.4 centimeters. Ratio and proportion is the method that Belinda likes to teach. I don't use this method, and I am really just going to read to you what she said because I never use this one. So a lot of you, this is going to be what makes sense to you, and then the rest of you are going to do desired over half times the vehicle, which is how I like it. So ratio proportion method is the algebra way to calculate the patient's dose. In the ratio proportion method, you will be given 3 variables, and you will be tasked with finding or solving for the missing 4th variable. So for example, a doctor orders oxycodone immediate release, 30 milligrams by mouth, sublingual every 8 hours as needed for pain. That's a very long order, but it makes perfect sense to me. The morphine comes up from the pharmacy in the strength of 10 milligrams per 5 mLs. I can't. Okay, I had to pause for a moment. So if there was an awkward bit of silence, that's why. Where were we? We were talking about what you have versus what you're giving. So using the ratio proportion, you will set up your equation with the units matching on both sides of the equation. So with this example, you would put 10 milligrams over 5 mLs equals 30 milligrams over X. Then you would cross multiply and solve for X. So working this problem out, you should get 15 mLs. We will practice this in lab, and you will also have one of the best math books that shows you hundreds of examples on how to work out these problems. If you don't like the ratio proportion method, like me, then you can use desired over have method. That's what I use. Simply memorize the equation in your long-term memory, put the numbers in, and solve. So using the previous example, a doctor orders Oxy IR 30 milligrams PO/SL every 8 hours as needed for pain, and it comes in 10 milligrams over 5 mLs. So desired, the doctor told me to give 30 milligrams. That's what I need. That's what I desire. What I have is 10 milligrams, and it comes in 5 mLs of solution. So that's my vehicle. So I have 30 milligrams, or let's see, I desire 30 milligrams. Let's see, I desire 30 milligrams. I have 10 milligram dose available, and the vehicle it comes in is 5 milliliters, which goes here. So then you take 30 divided by 10 times 5 mLs, and it equals 15 mLs. So notice you get the same answer no matter which method you use to solve it. Math is awesome like that, so no matter which method you like or you want to choose, you should get the same answer. So each student can utilize whichever method makes the most sense to you. And I can tell you I was never a big math person, and it always gave me math anxiety. This desired over have works for me every time. I get it. I don't know why. It just works for me. So there's a little bit of difference when you're doing pediatric calculations. And I know we're dealing with geriatric population in block 1, but we also teach you how to do the pediatric calculations in here. So infant calculations are a bit different. With infants, you will typically weigh them in pounds and ounces, which I kind of gave that example early on. And so the first thing you have to do is take the actual ounces and divide that by 16. And the reason you have to do that is because there are 16 ounces in a pound. And you want to know what fraction of a pound we have, or what percentage of a pound we have. So you take the ounce you're given and divide it by 16, and then you're going to get a ridiculously tiny number, and that's okay. You're going to add that low number to the given pounds that you have, which was the actual pounds. Then you go to take that number and divide it by 2.2, because that'll convert it to kilograms. And then you round to the nearest 10th place at the end. So here's an example. You have an infant that weighs 30 pounds, 7 ounces. So you take the 7 ounces and divide it by 16, which will give you 0.4375. Then you take your 0.4375 without rounding, the whole number it gives you, and add the 30 pounds to that to come up with 30.4375 for the actual weight. And then you take the weight and divide it by 2.2 to convert it to kilograms, which gives you 13.835227. You round it to the nearest 10th place. So you say, okay, so I have 13.83. And so that gives me 13.8 kilograms. When you ask us for more practice questions, we're going to refer you back to your hanky book and your Karch book, because there's a ton of resources in there. So make sure you go and look at that book to figure out more problems. And if you have any questions on this math, feel free to give us a quick email, and we're happy to spend a little bit more time on it. But we're going to spend plenty of time on it before that exam. Thank you again for tuning in.